Okay, so we've got this interstellar object, 3I Atlas, and it's making its closest pass to our sun right now. You'd think we'd be getting our best look ever, right? But instead, the scientific community has gone completely, weirdly silent. So let's dig into why. This is the big question, isn't it? This thing made a close flyby of Mars around October 3rd, which should have been a perfect opportunity for us to get some amazing data. We've got all these high-powered official instruments pointed at it, or we thought we did, and yet we've heard nothing. Crickets. What is going on? So the only new information we have so far, it comes from a really unlikely source. I'm talking about a rover that's designed to study rocks on the surface of Mars. Let's take a look at what it managed to see. Yeah, you heard that right. Perseverance wasn't built for this kind of work at all. It just so happens that it takes these nightly snapshots of the sky and dumps all the raw, unedited data onto a public server. And in an incredible stroke of luck, its camera was pointing in just the right direction at exactly the right time. But that raw data was super noisy, so it actually took two really clever amateur astronomers to make any sense of it. They downloaded the raw files, stacked dozens of these long exposure images on top of each other, and used some pretty advanced processing to clean it all up. On the left, you can see what they started with, just a very faint, fuzzy cloud. But look at the right. After their work, you can just make out a central point, a nucleus, and even a diffuse green haze, a coma, around it. I mean, this is an absolutely incredible piece of citizen science. So, look, the most important thing from these images isn't really what the object looks like. The data is way too low quality for that. The real takeaway, the big news, is that 3I/Atlas was exactly where our orbital math said it would be. That's a great sign. But that's pretty much where the good news ends. And this brings us to the most bizarre part of this whole story. While these amateurs were busy working with scraps of data, the heavy hitters, the big space agencies, were completely silent. A total wall of silence. These are the instruments that should have given us our sharpest look ever. I mean, the high-rise camera on the Mars Reconnaissance Orbiter, people were so excited for those images. NASA, the European Space Agency, all of them had said they'd be taking a look. And yet, as of right now, not a single official image has been released to the public. Nothing. This quote from our source material just nails the frustration, doesn't it? I mean, who knows why? Maybe it's standard procedure, maybe data processing is taking forever, maybe it's even related to the US government shutdown that was affecting NASA. But whatever the reason, the result is the same. The public is totally in the dark, and we're relying on a rock rover to get information about a major interstellar event. It's sad. And if you think that's bad, the problem is about to get so much worse. That little tiny window we had for observation for Mars, it's closed. And now we can't see the object at all, from anywhere. We are flying completely blind. And here's why. It's an astronomical event called a superior conjunction. As you can see, the object, the sun, and us here on Earth are all lined up, with the sun sitting right in the middle. Its glare is so intense, it's basically a giant cosmic photobomb, making any kind of observation from our neighborhood totally impossible. And this timeline just shows how awful the timing is. I mean, you couldn't write it better if you tried. We are going to be completely blind for about 6 weeks, and this is happening precisely when the object is going through its most active, most interesting phase. It's perihelion, its closest approach to the sun. This is when a comet would light up, and we have absolutely no idea what's happening to it. So you have this total vacuum of information, right? And what happens when there's a vacuum? Misinformation rushes in to fill it. A really compelling but completely wrong photo started going viral online, and it caused a huge amount of confusion. And this is the image. People were freaking out. They claimed it was proof of a cylindrical shape, some kind of glowing craft, something technological. It even got voted Image of the Week on a public NASA feed. So, is this it? Is this our first real look? Okay, let's break this down. No. First off, the image wasn't even from the high-quality camera used for the real sighting. It was from the rover's low-res navigation camera. And the object, it's not 3I Atlas at all. It's Mars's own moon, Phobos. And that weird, long, cylindrical shape, that's just an illusion, a motion blur, created because the camera's shutter was open for a while as the moon zipped across the sky.
Now, what really threw gasoline on the fire was an article from a pretty well-known astronomer, Avi Loeb. He published a piece analyzing this exact image, the picture of Phobos, as if it were 3I Atlas. He only clarified way at the end of the article that the ID wasn't certain, but by then the damage was done. His analysis got a lot of people whipped into a frenzy and made the misinformation seem a whole lot more credible.
So, here we are, stuck waiting in this blackout period. And this whole episode, it really forces us to ask some bigger, kind of unsettling questions about our place in the universe and our ability to actually keep an eye on it. I think this analogy from the source material is just perfect. It suggests that for all our amazing technology, we're still basically toddlers, unaware and unprepared for what's happening just outside our own cosmic sandbox. So really the core problem is this. This whole event has just exposed some massive gaps in how we watch our own solar system. We're blind at the absolute worst possible time. We've got pretty much all our eggs in one basket, observing from here on Earth. And when you're dealing with something that has even a tiny, non-zero chance of being really unusual, that is a huge risk. We just don't have a system of telescopes placed around the solar system to give us a continuous 360-degree view. And in the end, it just comes down to this simple idea. The Scouts' motto, be prepared. Because whether it's an asteroid or something much, much weirder, the universe is full of surprises. This whole thing with 3I/Atlas has been a really sharp reminder that right now, we are not prepared. And that's really the question this whole strange affair leaves us with, isn't it? Yeah, 3I/Atlas will pop back out from behind the sun in December, and hopefully we'll get some real answers then. But the real mystery it's uncovered isn't what the object is, it's why we've made it so incredibly difficult for ourselves to even find out.
Welcome to The Debate. Our focus today is the observation of 3I Atlas. This is a fascinating interstellar object that, well, it recently made a very close pass by Mars, something like 0.2 astronomical units away around October 3rd and 4th. This event, well, pretty thrilling, has been quickly followed by a period of, let's say, profound difficulty.
Indeed, yeah. Atlas is now heading into superior conjunction, which kicked off around October 21st. Now, for listeners who might not track celestial mechanics, daily, superior conjunction basically means the object passes behind the sun from our perspective here on Earth. This makes Earth-based observation, well, effectively impossible until early December.
Precisely. And this period of observational blindness, it's critical because it covers Atlas's closest approach to the sun, its perihelion, which is scheduled for October 29th and 30th. So the central question we really need to address is this. Does the current delay and frankly, the lack of publicly released high-quality observational data from assets we already have positioned near Mars, like, MRO's HiRISE camera or ESA's Mars Express, does this reveal just temporary, frustrating logistical hurdles, or does it expose something deeper? A fundamental systemic failure in global space agencies' preparedness and, importantly, their public communication strategies when it comes to time-sensitive interstellar objects. My view is that this prolonged information void highlights a dangerous systemic failure of preparedness and strategic oversight.
Okay, I see why you might feel this is a crisis of infrastructure. But I'd argue that the delays we're witnessing, while, yes, immensely frustrating, I get that, frustrating for the public and researchers who really want this data, they're primarily the sort of predictable result of overlapping, though temporary, logistical constraints. We're dealing with things like governmental funding issues affecting NASA, rigid scientific verification protocols, and, let's be honest, processing pipelines that just weren't designed for this kind of exceptional, urgent data capture. It's more of a procedural bottleneck, I think, not a fundamental strategic failure.
See, the distinction between procedural failure and strategic failure feels pretty thin to me when the procedure itself is inherently unfit for a unique, time-critical event like this. My position is that the current inability to release or even rapidly confirm the capture of high-resolution data, well, it exposes a strategic failure, a failure to anticipate the requirements for observing such a rare, rapid transit interstellar visitor. I mean, It's a striking vulnerability that we've been forced to rely solely on the, yes, dedicated and brilliant efforts of amateur astronomers, using raw, low-res images from Perseverance's mass cam just to confirm the object's basic position. Why is the gold standard data, the high-res imagery from MRO, which we know is capable of extreme surface detail, why is it still completely unavailable days after the imaging opportunity? It really suggests that our observation strategy had, well, all its eggs in one basket here on Earth, and that our Martian assets lack the necessary priority routing for critical, fleeting targets. And this oversight, it takes on added weight when we consider the, let's say, non-zero possibility of the potential technological nature of such objects, even if that possibility remains remote.
I understand the frustration about the data gap. I really do. But calling it strategic oversight perhaps minimizes the technical and governmental realities at play here. Let's look at some mitigating factors. HiRISE, right? The instrument everyone wants data from. It's fundamentally designed for static, high-contrast surface geology and mineralogy. It is not optimized for faint, non-sidereal tracking of a fast-moving, diffuse cometary object deep in space. So the processing pipeline required to extract usable scientific data from a target like Atlas is entirely non-standard. It just is. Furthermore, we really cannot ignore the ongoing governmental limitations in the United States, which directly impact NASA's ability to staff the personnel necessary for specialized, non-routine data processing, verification, and clearance. The delay isn't necessarily evidence of malice or intentional withholding. It's more likely the natural consequence of requiring highly specialized engineers and clearance personnel to route unique data through a system that's, well, temporarily crippled. And critically, the limited data we did get from the Perseverance public feed allowed that rapid amateur analysis, which confirmed Atlas was precisely where prior measurements predicted it would be. The trajectory seems stable. The urgency of knowing its precise location minute by minute is somewhat mitigated by this orbital stability, wouldn't you say?
While the amateur validation of the orbital path is certainly reassuring, it doesn't, in my view, excuse the silence regarding the high-resolution imagery itself. The speed with which amateurs like Astronomy Live could process the low-quality mass cam data, taking what, a day or two to stack 36 to 40 exposures, makes the prolonged silence regarding the high-rise captures seem highly questionable. Even if we grant the complexity of the specialized pipeline, the lack of any official statement simply confirming, yes, we secured the necessary captures on October 4th and processing is underway. That raises significant concerns regarding strategic communication protocols. The scientific community needs that immediate confirmation, especially given the shutdown context. If the raw files exist, a simple confirmation isn't hindered by calibration needs, surely.
Well, my contention is that we can't really conflate the relatively simple act of stacking long-exposure navigation images, which, let's face it, essentially just confirms a location, with the rigorous multi-layered process required for releasing verified scientific data from an instrument like HiRISE. High-resolution imagery demands sophisticated calibration that goes way beyond standard procedure when you're tracking a faint comet. We're talking about critical steps like creating and subtracting numerous dark frames, correcting for detector noise patterns unique to that specific instrument, and ensuring the complex geometrical transformation from the Mars-centered observation perspective back into a verifiable heliocentric coordinate system. For an expert audience, the distinction is crucial. Raw data may be suitable for amateur confirmation, is available quickly through public feeds. Verified, peer-review-ready scientific data, the kind suitable for official release in serious analysis, must follow protocol. And that protocol, well, when the standard processing personnel are furloughed because of a government shutdown, it inherently slows down. We have to respect the integrity of the data. Cutting corners on verification just for the sake of speed is, frankly, counter to good scientific practice.
Okay, I appreciate the defense of rigorous scientific protocol, I really do. But it leads us right back to the larger strategic failure, doesn't it? Why does our species lack a dedicated, high-powered observational asset in the inner solar system, specifically for tracking incoming objects, when Earth-based viewing is impossible? I mean, the superior conjunction observational gap is a predictable event. We knew this was coming, and now we are fundamentally blind during the critical period of perihelion. This isn't just about Atlas, it's about planetary defense, it's about general astronomical curiosity. The lack of a functioning inner solar system telescope, a sentry, if you will, dedicated to intercepting and tracking transient objects like Apophis or these interstellar visitors, it just underscores that humanity's observational posture is dangerously parochial. We're operating like a single planet species, not a species concerned with the larger cosmos and its potential hazards. We should be having serious discussions about dedicated small-sat constellations or even a specialized orbital mission designed specifically for this tracking role.
Well, the idea of a dedicated inner solar system sentinel is intellectually compelling. Absolutely. We have to weigh the astronomical costs and trade-offs involved. Placing and maintaining a Hubble-class instrument in, say, a Venus trailing orbit, or even a specialized deep space probe, it requires immense funding and, critically, a lot of propellant to maintain stable station keeping against orbital drift. Resources are finite, let's be realistic. Prioritization has to focus on the high probability scenarios, primarily near-Earth objects, which pose a known quantifiable risk. Developing and launching a mission specifically dedicated to objects like Atlas, which, let's remember, appear maybe once every few years, requires diverting funds from ongoing high-priority planetary science or proven Neil Wise-style surveys. Furthermore, the claim that we are totally blind during superior conjunction might be a bit overstated. There remains a possibility, maybe small but non-zero, that 3I Atlas will become bright enough to be visible on the SOHO C3 coronagraph view during the occultation period. SOHO, which monitors the sun, is an existing asset that sometimes can provide crucial tracking continuity for bright comets near the sun. So it could potentially mitigate the complete observational gap you're describing. If Atlas is large and bright enough, SOHO C3 might very well give us the necessary data points during perihelion.
Ultimately secondary resource constitutes a viable mitigation strategy for what should be a primary strategic objective: continuous tracking of interstellar objects. And that brings us directly to the communication failure that inevitably fills this kind of information vacuum. Agencies and experts, they need to be extremely careful with public communication concerning time-critical events, especially when official data channels go silent for days. The resulting chaos, where misinformation just rushes in to fill the void, it's predictable. A perfect example is that whole incident where an image of Phobos, Mars's moon, whose name ironically means fear, was widely mistaken for 3I Atlas. And this confusion was fueled, let's be fair, in part by experts who posted the image without clear, explicit disclaimers right there in the title or easily visible, allowing these wild claims, like the object being cylindrical, to spread like wildfire. This isn't just a PR issue, it's a crisis of institutional confidence, and it's caused directly by the slow, bureaucratic nature of the data release itself.
That's a compelling point regarding the strategic missteps in communication, definitely. But the blame, I think, needs to be accurately apportioned. The elongation seen in that widely circulated Phobos image, that was purely an artifact of the low-resolution navcam taking a long exposure while both the moon was moving and Mars was rotating relative to the frame. The confusion wasn't malice or some intentional misdirection. It was public misinterpretation of a low-quality diagnostic image coupled with, yes, media sensationalism, focusing on the dramatic non-zero probability angle. Conversely, the success of the amateur astronomers in processing the higher-quality mass-cam data actually showed that the scientific reality, a faint, diffuse green coma, consistent with expected cometary activity, was established relatively quickly. The access to that raw data stream, even low quality, provided the necessary antidote to the misinformation reasonably rapidly, suggesting that transparency mechanisms we do have, despite their limitations, are functioning to some extent.
I'd argue that those transparency mechanisms are functioning despite rather than because of the official protocols. The hard fact remains. We are entering a month-long observational hiatus covering Atlas's closest approach to the sun without even having confirmation of the high-resolution data capture that was specifically planned for this very encounter. The 3I Atlas event is a powerful and potentially expensive wake-up call. It emphasizes that our global space observation strategy is fundamentally unprepared for the unique challenges presented by rapid, rare interstellar events. Relying on low-quality public feeds while the crucial high-resolution scientific data remains bottlenecked by bureaucracy and budgetary constraints, it highlights a severe strategic gap in global preparedness and transparency that needs immediate remediation.
I agree that the data gap is inconvenient, definitely, and it necessitates a review of our rapid response protocols. But I would caution against framing this as some kind of existential or systemic failure across the board. The current situation seems largely attributable to very specific, temporary, and, importantly, external factors. The confluence of a government shutdown impacting key personnel and the rigorous processing requirements inherent to using highly specialized equipment like HiRISE that was simply never designed for this particular application. And crucially, let's remember, the limited data we did successfully acquire and validate confirms that Atlas is behaving predictably, continuing on its expected trajectory. That underlying certainty mitigates the most pressing concerns, the threat of an unexpected or dangerous deviation. And it allows us to attribute the current delay mostly to logistical friction, however frustrating that friction might be.
So it sounds like while we may agree that a post-event review of these protocols is vital for improving future interstellar object tracking, our fundamental disagreement really rests on whether this observed data void is just a manageable operational hurdle or if it's actually a symptom of a larger, perhaps chronic, failure in risk prioritization and strategic resource allocation across global space agencies.
Precisely. Yeah, we agree that the data matters immensely, but we differ significantly on the level of, let's say, existential urgency and the necessary infrastructural investment required to mitigate this specific type of risk, especially considering the very real constraints of terrestrial budgets and the statistical rarity of these events. The lessons learned here about balancing procedural rigor with rapid public access, well, they will certainly be scrutinized very closely, regardless of the ultimate outcome of 3 Atlas itself.